So there's more than one way to express concentration. Molarity is preferred in chemistry. Okay. But here are some examples of some components in seawater as well as human serum. So in other words, like blood, you know what I mean? Okay. And notice it's expressed in grams of solute per kilogram of solution, or kilogram of solvent rather. Let me just double check that for you. Yes, so that's grams of solute per kilogram of solution. We could also express it in millimole of solute per kilogram of solution, or even just in millimolar. Okay, right? So if molarity is mole per liter, I can also have a millimolar. I know that gets really confusing, little m and big M. So, but millimolar means 1 times 10 to the minus 3 moles in 1 liter. Okay? I could have micromolar. Micromolar means 1 times 10 to the minus 6 moles in 1 liter. I could even have nanomolar, which would be 1 times 10 to the minus 9 mole in 1 liter. So recognize that we can apply our unit analysis to this concept of concentration. And that actually makes things much more useful because look at the concentration. So in seawater, not surprising that sodium is the highest component as well as chloride, right? Seawater is very salty, and it's mostly sodium and chloride, okay? But now when you look at things like fluoride or even strontium, look, the concentrations are tiny. Teeny, teeny, tiny. I mean, even for the strontium too, look, this is being expressed in millimolar, okay? And it's still like 0.0928 millimolar, so maybe using micromolar would be best. And then if you look at the concentration of these ions in human blood, look, it's tiny. Less than 3 times 10 minus 4 for strontium 2, okay? Or even for, let's find some other ones that we, I don't want to quite talk about this thing yet, okay? But like if we look at, I don't know, let me find a small one here besides the strontium 2. I mean, even magnesium is really small, okay? So there are other units we can use to express these concentrations, more useful units. And one of those is the part per million, okay? And so what part per million means, if you have one solute, okay, then you have 1 million of the solvent. So that's what 1 part per million means, okay? For every one of these, for every one solute you would have 1 million molecules that are the solvent. So there's some more useful ways to express this for solutions. So let's follow through this, okay? So this is a microgram per gram, okay? So a microgram is 1 times 10 to the minus 6 grams. So there's our part per million, right? Instead of saying like for every one solute particle, I have 1 million. Let me write this up over here actually. So instead of saying like what I said right here, okay, for every one solute molecule, I have 1 million solvent molecules, or excuse me, solution molecules. Really, I should say that, okay? More correct to say solution. I could also then say, well, if I have 1 microgram of solute, that's the same ratio as 1 gram per solution, okay? And so now follow through the line here. So a microgram is the same as, or rather I should say 10 to the 3 micrograms of solute is the same as 1 milligram. So this gets a little confusing, so follow through here. So 10 to the 3 micrograms is the same as 1 milligram. Okay? So now that 1 milligram, look, it stays. All right? And then now let's follow the gram solution. Okay? So follow this all the way here, right? 1 gram of solution. Now what I can say is in 10 to the 3 grams of solution, it's the same as 1 kilogram. So an equivalent of 1 part per million is also 1 milligram of solute per 1 kilogram of solution. And if I back up on the slide right here, we have here grams per kilogram, right? But let's find one that's roughly 1 milligram. So let me pick on this strontium right here, okay? So 0.00794 grams. I'm going to convert that to milligrams, okay? So I know in 1 gram, there's 1,000 milligrams. So that equals 1, 2, 3, 7.94 milligrams. And look at the unit. It's 7.94 milligram of solute per kilogram of solution. And let's go back to this next slide here. Let's go forward. 1 milligram of solute per 1 kilogram of solution is the same as a part per million. So here we go, 7.94 milligrams of solute per 1 kilogram of solution. So this is the same thing as 7.94 ppm, part per million. And so when we look at this unit, you're going to hear me say this often, chemists are lazy. We like to express things in something that's easy to say or write. So instead of saying 0.00794 grams of solute per kilogram of solution is the concentration of strontium 2+, it's so much easier for me to just say it's 7.94 part per million. Right? That took way less space, way less time to write. All right? And we do this often in chemistry and in other forms of science. We convert units around just to make it easier for ourselves to express things. Okay? So for example, right off the bat, I can say this fluoride concentration, if I look at it right here, oh, actually, I think I had that as an example. Yes, express the concentration of F- from table 4.1 in part per million. Okay, so let's break that down again. So that's 0.00130, and that's going to be grams of F- per kilogram of solution. All right? So we can keep the kilogram of solution. That's all good, right? I don't need to do anything there. But now I want to convert this grams of F- into milligrams. So I can say 1 gram of F- is the same as 1,000 milligrams. Okay. And now that gives me, move the 3, 1, 2, 3. That makes it 1.30 milligrams of F- per kilogram. I'm going to start giving you my abbreviation for solution. I say sol apostrophe T. That's how I abbreviate solution. And so 1.3 milligram of F- per kilogram of solution, that's the same as just saying 1.30 part per million of F- in seawater. And that's just much easier to say. Okay. So I'm going to move forward.